All right, so in this video, we are going to be talking about what happens when E is bigger on top. So to review, when it's bigger on bottom, Y just equals 0, which is easy. When the degrees are equal, we look at the leading coefficients and we take the ratio of them. But for this one, it's bigger on top. See, 3 to 2. So the degree is bigger on top. We have to use long division. If you look at the first one had a degree of 3 on top and 1 on bottom. With that linear on the bottom, you could use synthetic, which I think is easier and most people do too, so I would recommend doing that. But for this one, when you have a quadratic in the denominator instead of a linear, you're going to have to use long division. So let's do that. So we're going to take what we're dividing by, put it here, and what we're dividing from right here. Okay. When we divide this, we just ask ourselves, what would I have to multiply x squared by to get x cubed? And that's just one more x. But I have to distribute all of this to that. So then I'd get minus x squared and minus 12x. Now I have to distribute a negative sign because I'm taking away this from all of that. So some people like to put the parenthesis there, like we did in class a long time ago. So now I subtract this. These obliterate. Boop. This will add to negative x squared. This will sum to 5x. And then we drop down the negative 4. All right, now I have to ask myself, what would I have to multiply x squared by to get negative x squared? And that's just the negative 1. It's going to give me negative x squared plus x plus 12. I now distribute the negative signs to change the sign. Beep, boop, boop. The x squareds cancel out, leaving me with 4x minus 16. Now, see how this degree is 2 and this degree is 1? This is now our remainder, and that's an r. The remainder does not help us for the end behavior equation. The only thing we want is the top portion, which is right here, this x minus 1. That is going to be our slant asymptote that the line will be bounded by. For those who probably only needed to see that, then this would be a good point to stop and start working. But I'm going to go through the rest of the problem just in case. So let's take a look at the r's. We have a root at -1 and 4. I'm going to erase this just for some space. And we also have 1 at 4. And by the way, the way I got that was by using the rational root theorem and synthetic division. I knew that my answers have to multiply to 4. 1 times 4 is 4. And also it can only be the factors of 4. And then same thing down here. This one I just did factoring by the quadratic, and it was 3 and 4. And notice they multiplied to 12. Now the asymptotes are going to be at x equals 4 and x equals -3. They're vertical lines, so they're x equals. There is actually some tendency or togetherness. We're looking for, if once we factored it, see how this answers once, once, and once. That would be none, but right here there is a even multiplicity. And that's going to make it bounce. So it's going to bounce at this root right here, the -1, 0. So it's going to bounce at -1, 0. You don't have to indicate where. I just like to write it. Now, our end behavior we got by doing the long division, and that's going to be y equals x minus 1. So it's a linear equation, and I'm going to draw that in a little bit. The y-intercept, we're going to let x equal 0 and find out where the y value is. When I let all this zeros out, and I get -4 divided by -12, which is going to leave me with 1/3. 1/3. Right? And now I have enough information to graph this equation. So I'm going to do a little drawing. Actually, I'll erase my work here and then hope everyone had a good Easter. Okay. Yeah, graphing. Whoop, beep. All right, so let's put our points in. We got one at -1, we got one at 4, and we have a y-intercept at 1/3. We have vertical asymptotes at -3 and x equals 4. Oh, take a look at this. I didn't notice this. Um, this is going to disappear, and so is this. Because up here, I forgot to notice that these are actually the same factor. So they're actually going to cancel out, creating a point of discontinuity, a hole. So in fact, at 4, we need to make sure we put a hole there on our graph. Sorry about that. So these are going to disappear. So it's just x equals -3. And we got that that hole there. Okay, so I'd like to actually write that hole at 4, comma something. We'd have to plug it in and find out where it is. All right, and now we need our slant asymptote. So we have, where is it? Oops, right here, x minus 1. So it's y equals x minus 1. Y equals x minus 1. And so it's going to start here at -1, and then the slope goes up 1 over 1, up 1 over 1, so up 1 over 1. Right? So now, I mean, when you get pretty good at these, for doing, like if you do them for a while, I know what they're going to do. They're going to look like this, and then there's going to be one down here. But let's just say you didn't know that. I mean, really, what the graph always does is it goes towards the asymptote, and it goes towards the asymptote. So it should make sense that it does that. And also, at this -1, we know it's going to bounce. Otherwise, it would have to go through. So we know at least this because of the information there. Now, I do know that there's no love, so it wouldn't be together. So I know it's going to be down here, but you could always test points. So you could plug in -4, and you would see that it is below this line and therefore down here. So you can always do that. But once you've done these enough, you kind of understand how they work. All right. And that would be our graph. So make sure you can see that I didn't notice at first that these crossed out. Only when I went to go graph it did I was like, oh yeah, these are the same. All right. Let me know if you guys want me to post another question. I only got asked to do number 2. But if there's another question you'd like me to do, I can. I also have the key online, so you can see. I think I did all of the problems, if I'm not mistaken. I did it a week ago. So, all right. I hope everyone's doing okay, and hope to see you guys soon. So.